I'm Bill, that's Damien, and that's Bray. And this is our Monopoly project on probability. Probability are the odds of something happening in a course of multiple sequences and so on. So we're going to look at it in the factors of Monopoly, card playing, such as Go Fish, and dice rolling.
So we're going to start off by showing you the probability of throwing one die. And since there's only 6 outcomes, that means that the probability equals 1/6. And so what is the probability of throwing 2 in a row? It would be independent of one another because the dice roll does not affect the other. Therefore, you just multiply 1 by 6, equaling 1 out of 36. So what is the probability that in 6 rolls of the die, you will not throw ever once a 2?
So the probability that you'll not throw any 2s is 6 factorial 1, 5 over 6 to the 6th power, 0 factorial 6 factorial, which equals 5 over 6 to the 6th power, which equals 0.335.
For example, if I rolled this one die 6 times, what would be the probability that I would roll a 2? Well, the answer would be 1 because there are 6 sides on a die, so yeah.
What is the probability that you will throw exactly 1 2 in 6 throws? To find that, you have to multiply the number of sides of the die by the number of chances it has to land on the 2, which brings you to 0.402 for exactly 1 2 in the sequence of throws. Now we're going to move on to Monopoly, which has dice rolling involved with it that we just figured out. And to describe Monopoly as a game of probability, you have to understand that the whole board has 40 spaces, and 28 of them are purchasable properties, and 6 are chance or community chests. Now we're going to move on to Monopoly, which has dice rolling involved with it that we just figured out. And to describe Monopoly as a game of probability, you have to understand that the whole board has 40 spaces, and 28 of them are purchasable properties, and 6 are chance or community chests, and 3 are just free ones. So we're going to go over what will happen if me, Damien, and Bray play Monopoly using 2 dice, which makes the probabilities a little more different because 1 isn't an achievable number and other numbers are more frequent than others. In order to find the frequency, you have to just take the number of outcomes possible that will equal that number and put it in terms of 36 because there are 36 total outcomes. So a sum of 2 is 1 in 36, a sum of 3 is 2 in 36, a sum of 4 is 3 in 36, a sum of 5 is 4 in 36, a sum of 6 is 5 in 36, a sum of 7 is 6 in 36, 8 is 5 in 36, 9 is 4 in 36, 10 is 3 in 36, 11 is 2 in 36, and 12 is 1 in 36.
Do you want to repeat that again?
No, I think it's pretty good. I think they're going to get it.
Oh, okay.
And so as you can see, 7 is the most common outcome because the dice 3 and 4, and 5 and 2, and 1 and 6, I think are all of them, are the possible combinations. 7 is the most common outcome.
Most common outcome.
So we are going to show you the probability of landing on all these spaces the first 2 turns of a game. So we're just gonna start playing. 7, baby, most common one. Chance, let's see what I got. Oh, go back to go, baby! Yes! Yo, wait, I need 200 right now. Snake eyes! Nice. For the community chest. That's all you, dude.
You got those, so you go good.
That's true.
Oh, pay hospital $100. I don't even have $100.
Right there, dog. Yeah, so you got snake eyes. 10.
Nice.
So. No, I think it's there.
Yeah, probably.
Alright. You want to buy it? Electric company?
Hell yeah.
Alright. So put the money over there. That's the bank. 150. Alright. Here you go.
Sweet.
Alright. Damien, your turn. 9. It's right there. You want to buy it?
Yeah, I'll take it.
Alright. Right over there. Alright. Here you go. Alright. So this is our second turn. Ooh, doubles again. Nice. 100. What is that one called? Vermont. Alright. Might go again. Yeah.
You gotta buy.
You gotta buy all the railroads. Tip. Buy all the railroads. Pennsylvania. Alright, your turn.
Oh.
10. Chance.
What was that?
It's the orange one. What does it say?
Go past go and collect 200.
What? I just had that one.
You go back to that.
Yeah, but he gets 200 again. What? I literally just got that one.
Definitely
It's ridiculousness.
Wow.
Damien's so black.
So, are you gonna buy it? You buy Virginia,
Yeah, let me check.
Virginia Avenue. Put the money over there.
How much is it?
160. This is the last one. Alright, cut it. Sign up.
Yeah, we gotta get away.
So, as you can see, after playing 2 turns, we got to many different places on the board. But the odds of landing on those spaces, we calculated ourselves, which was using 1 out of 40 and using the dice rolls as well. Community chest was a 1 in 36 chance. Baltic was a 2 in 36. Income tax was 3 in 36. Reading Railroad was 4 in 36. Oriental was 5 in 36. Chance was 6 in 36. Vermont was 5 in 36. Connecticut was 4 in 36. Just visiting jail was 3 in 36. St. James was 2 in 36. And Electric Company was 1 in 36. And that was on your first roll. All those were possible. So, this is a combination of different rolls you could have had. And then it ends up showing the grand total of that whole outcome occurring. So the probability of rolling a 2 and a 5 is 1 in 36 multiplied by 4 in 36, which is 4 in 1,296. And the next rolls are also out of 1,296. And then you have to add them all at the bottom, as you see. And it equals 1.54% of the whole outcome. And that is the probability of that particular roll, which shows how rare certain rolls really are.
Alright, so the next game we're going to play is Go Fish. The next game we're going to play is Go Fish. The reason cards are different from games we've been playing is because cards are dependent on each other. Because once you remove one card from the deck, the odds change. 52 cards, each designated by one of the 4 suits and one of the 13 numbers. Therefore, the odds of getting an ace as your first card are 1 in 13, which is 7.7%. While the odds of getting any heart as your first card are 1 in 4, which is 25%. Unlike our other examples, cards independent of one another every card dealt changes the makeup of the deck. For example, if you get an ace as your first card, only 3 other aces are left among the remaining 51 cards. Therefore, the odds of receiving another ace are 3 in 51, which is 5.9%. Much less than the odds were before we received the first ace. In order to find the odds of getting dealt a pair of aces, we multiply the probabilities of receiving each card. For example, 4 over 52 times 3 over 51 equals 12 over 2,652, which is equal to 1 over 221, which is approximately 0.45%, and so on.
All right, so we are going to go over the probability in a game of Go Fish of starting with pairs and seeing how many pairs we can get in the first two rounds. So we already drew. I started with a pair of 3s. That's that. Bray, your turn.
Damien, give me that 2.
All right, Damien, you're up, dog.
Do you have any 4s?
Go Fish. Brayford, do you have any queens?
Go fish, buddy.
All right.
Jacks.
Go fish.
Got any jacks?
You got any fives?
I do. All right. Damien, do you have any fours?
Yep.
Any sevens?
Go fish. Bill, you got any kings?
Go fish. All right, so we don't take up too much time. We just played 2 rounds, and as you can see, Bray already has 3 pairs. I have 2 pairs. Damien has 0 because Damien's not very good at Go Fish. I know.
I'm the winner.
And that's that. All right, so as you can see, we use probability in many different everyday things. Games are a big part of them, and there's many different ways to find probability. You find the odds, you multiply, you add. And every probability is different. There's dependent ones and independent ones. The independent ones are dice rolls, dependent were cards because they've changed every time you took a card. And everyday life just has probability. So you never know the odds.
Yeah, pick up these cards.
Yeah! If you roll a 7, we get 100.
Yo, I haven't.
Yes! Yes!
Wait.
Not my not big win, but it's cool.
You need all that.
I'm gonna have to because we have to show them that. Can I see that, Braxton? Alright, so we're starting a game of Go Fish, and we're now going to see the probability of starting with the cards. We're going to play 2 turns and see how many different pairs we can get before we end those 2 turns. So I started, I already have a pair of 3s, and that's it. You can start, Brett.
Alright, Damien. Got any 2s?
Go fish.
Dang.
What do you...
I don't know how to.
So we're going to start off with showing you the probability of 1 die being thrown at a time. So what's the probability of throwing a 2? Since there's only 6, that's what it says.
That was perfect.
Just read the paper.
Intelligente.
Read the paper!
Come on,
I am hungry!
Change your grill.